This picnic table is a great project too because it solves a problem that you see in all wood picnic tables, and that's that they're not always as strong as you'd want them to be, but even when they are, you have the rot problem. That wood, all that wood in contact with the ground. It's not unusual for picnic tables to, not really, wooden picnic tables to not last all that long because of that rot problem. This design completely solves that problem. It's made of 2 inch by 2 inch square tubing. It's a big and impressive project, but it's actually pretty easy to make too. It's not complicated at all. And of course, it's got wood on the top for eating on, so it's nice and comfortable. And it's a simple project. 2 by 2 square tubing is easy to find. So let's look at a few details on the plans to get you going in the right direction. This project really comes down to the ability to cut 90-degree ends and to weld 90-degree joints. There's a lot of 90s here, as you can see. It's not complicated, but that's really where the precision of this project comes in. What you couldn't see in the photograph before were these angle iron pieces. This is the table support. It holds the boards. This is the seat support. It holds the seat boards. And in both cases, these parts need holes drilled for a lag bolt that will go in and hold the boards. This is a perfect situation for using step bits in a drill press. You can drill these holes by hand with a handheld drill, but it's quite a bit more work, mostly because a handheld drill can't develop the kind of pressure that a drill press can. Now, if you were observant, you may have noted that the end of the bottom piece here is covered in the picnic table in the photo. And here in the plans it's shown open because the joint of the seat upright sits on top of the bottom piece. So left to its own devices, this would be open. You can leave that open if you want, or for a neater look, you can also cut a piece of plate steel and weld it on the end, capping the end. My only warning would be if you are going to cap it, that you want to make sure that the joint is completely waterproof, because this bottom piece is going to be sitting on the ground, and if there's a hole there, a little hole in the weld, in the wet season it can fill up with water, and if you live in a cold climate like I do, that water freezes and it will expand and it can actually crack the steel. There's nothing that can stop the expansion of freezing water, not even steel. So if you are going to cap it, do a good job. Make a nice weld bead and keep that water out completely. In the instructions coming up for this project, you're going to learn about a technique that's very useful in lots of applications, and it's a method for getting square assemblies when those assemblies are large. I mean, you can use a reference square to say, make sure this is 90 degrees and this is connected at 90. You can use a square, but the larger the item you're attempting to square up, the less effective squares are, because a little bit of deviation on the square will end up being quite a large error in the finished project. So what I recommend, and this is something that you're going to use again and again in your welding work, and that's to use a level in order to create square assemblies. And the way you do that is, in this case, by making the bottom level and shimming it up as necessary in case your floor is not level. And then if you put that same carpenter's level on this upright and you make sure that it's plumb, so straight up and down according to the bubbles, the bubble in the level, then you're going to have a square assembly. You can also use the corners and edges, the factory corners and edges of plywood. Most plywood, certainly in North America, have remarkably square corners, and so that's a large and useful reference edge for you to follow. So that's another approach, but using the levels is very, very powerful. Once you have this assembly put together and you have the upright, then you can continue to use the level. You put the level on and you check that the table support is horizontal before you weld it together. And it's surprising how accurately you can bring things together in a square way, large assemblies like this, using a level to determine what's horizontal and vertical, and then work from there.